Okay, a very good morning and welcome to all students of 5 Paiduri and 5 Citrine. So, do you have already take your dinner? Sudah makan ke semua? Okay, welcome Chunyao. Before we begin with our lesson today, so this is the schedule for physics extra classes involving 3 classes of Arcade Baiduri and Citrine. It will be conducted every Tuesday and Friday 8:30 to 9:45 p.m. via Google Meet. This is effectively on 11 to 28 October. So if you count, we are going to have 6 sessions altogether started from tomorrow night. Okay, student, tomorrow I won't be in school since I have to attend a seminar outside. So we will start with these extra classes tomorrow evening as shown at the time that 8:30 p.m. until 9:45 p.m. So please mark your calendar. This is the schedule for physics extra classes. Okay, we try our best to finish with the syllabus before you sit for your trial exam on this October 31st. Okay. So I hope you're all ready and good to go. So our session tonight will be discussed page 12 until page 16 or 17 in your module. So I hope you are ready with them. So this is where we stopped last time in school. We have discussed the two example of experiment which affect the resistance of a wire or conductor. And this evening, student, we are going to continue with the third example of experiment to discuss another factor affect the resistance of a wire. So anyone remember the 4 factors affect resistance in a wire? Can you list them in this in-call messages? Or you can open your mic if your mic are available. Yeah, temperature, length, another 2. 4 factors affect resistance of conductor. Size, what size, Xiang? Be more specific. Temperature, yes. Length, yes. Others also can respond. 4 factor affect resistance of conductor. For the size, you can write cross-sectional area. It is cross-sectional area. So another one, what is it? Another one is as you can show in this screen now, the 4th factor affect resistance of wire. How are you live at school? Okay, look at the screen, experiment 3.4. What is the factor affect resistance of wire here? You can read from my screen now, experiment 3.4. The resistance of wire depends on resistivity. So the 4th factor is resistivity of wire. So what is resistivity? We are going to discuss that after we finish discussing this experiment 3.2.4 is to define what is meant by resistivity of wire. Okay, so this is the experiment related as shown in your module page 12. The inference and hypothesis are as written. The resistivity of a conductor increases, so the resistance increases. So you can say resistivity is directly proportional to resistance of wire. Welcome, Jeb. We are just started with experiment 3.4. Another factor affect resistance of wire other than length and temperature. So it is called as resistivity. So you can turn to your module page 12 for this experiment. So student, please fill up your module with all these particular. The aim is to study the relationship between resistivity and resistance. And all the variable are as written there. MV is RV and CV. Apparatus and material required for this experiment are as listed. You need a dry cell, cell holder, a switch connecting wire. We need ammeter. Ammeter is to measure the current flow in the circuit. Voltmeter to measure the voltage. Okay, then crocodile clip, a rheostat to adjust or to manipulate the value of current in this circuit. meter rule, Constantan wire and nichrome wire with this SWG24. Remember, SWG of wire determines its cross-sectional area, and the wire is at the length of approximately 35 centimeter each. So in this experiment, we keep constant the SWG and the length of wire. So we are using different type of wire. Different type mean they are different in resistivity. Okay. So if you don't have, for this apparatus and material, you can write them later, because after we end this session, I will share to you the full PDF copy for 3.2 resistance. So we try to save our time here. So you just copy the inference until variables first. For apparatus material, you can write them later. All right. So can we move to our next slide, students? Okay, so let us see what is an example of result for this experiment. Okay, students. Okay, so this is the procedure from number 1 for until number 6. This is the related diagram to this experiment. So can you make some correction on procedure number 3? The current flow in the circuit is 0.1. Okay, so you erase 0.5, you change to 0.1. We adjust this rheostat, and making the current flow in the circuit is always at 0.1 ampere. Okay. So we record the voltmeter wire, the voltmeter reading for Constantan wire first, and then we calculate the resistance from this formula by calculation. Okay, then we repeat this experiment with different type of wire, which is nichrome. Okay, and this is the example of result you can get for Constantan wire. The potential difference across the voltmeter is 0.06, while for nichrome, the potential difference read in the voltmeter is 0.16. So when you count the resistance, students, how to find resistance? V divide I. Voltage divide current. So it will be 0.6 for resistance and 1.6 for nichrome. So anyone, what can you say about this result? What can you say about Constantan and nichrome wire in terms of their resistivity? Which one has higher resistivity? Which one has lower resistivity? Okay, so how we write? Can you respond to this question? What conclusion can be drawn from this experiment? So you can say that the resistance or the resistivity of nichrome wire is larger than the Constantan wire. So you can see clearly when the resistance is higher. So it means nichrome has a high resistivity because it has high resistance compared to Constantan wire. Okay, remember this experiment, we want to relate resistance and resistivity. So we understand from our result, nichrome wire has higher resistance compared to Constantan wire. So it means nichrome wire has a higher resistivity compared to Constantan wire. Okay, are you clear with the result and conclusion for this experiment? Okay, 5 Baiduri, 5 Citrin. Okay, so this is a discussion we can, or the conclusion we can write from all these 3 experiments. Remember earlier in experiment 3.2, we discussed what is the relationship between resistance and length of wire, where they are directly proportional. When the length of wire increases, resistance also increases, mean longer wire has higher resistance. And this is what we find out in experiment 3.3, the relationship between resistance and cross-sectional area of wire. They are inversely proportional. Remember, we have discussed when the cross-sectional area of the wire is bigger, so the resistance will be lower and vice versa. So when we combine these 2 relations, this is what you will have. R directly proportional to L, inversely proportional to A, where R is the resistance, L is length, A is cross-sectional area of the wire. And if you convert this into mathematical expression, if you write this into mathematical expression, so what will it be? It will become R equal rho L divide A. So there is one constant value there, rho. So this is what resistivity, okay? It's known as a constant. It shows the resistivity of a conductor. So this is the formula you can apply to determine resistivity of a wire when we are given the resistance, length, and diameter, cross-sectional area A, okay? Okay, so that's all with 3.2.3. 4 factors affect resistance in a wire. I repeat, they are length, cross-sectional area, temperature, and resistivity of wire. Okay, and we have 3 examples of experiment to study the relationship for each, where in each 3 experiment, the temperature of the wire is always keep constant. Okay, can we move now to our 4th learning standard student? What is resistivity of wire? The symbol is rho, similar symbol to density, rho, but they have different meaning and different SI unit as well. Okay, so to understand resistivity of a conductor, you can write resistivity. It's a look quite long there, so do you need to write all? This is to write where? To write on page 13 in your module, the definition for resistivity. So you can write the highlighted word only. Okay, you can write the shortcut for this point. So what is resistivity, student? It is the conductor's ability. Okay, so you just write conductor's ability to oppose the flow of electric current through the conductor. Okay, this is the definition for resistivity. It is the conductor's ability to oppose. Oppose means what, students? Oppose. Oppose means what? Oppose means to resist, to say no. They don't want current to flow through it. So they reject current. They oppose, resist current to flow to them. Okay, so this is the definition. And then second point, you can write SI unit is ohm meter. Okay, that's all. Second point. First point, you write the yellow word. Conductor's ability to oppose the flow of electric current. Second point, you just write SI unit is ohm meter, unit for resistivity. And the third point, okay, this is the additional point. You can write the value for resistivity is depend on temperature and the nature of the conductor material. It means different type of material or different type of wire, different type of conductor, they have different resistivity. What is meant by the word nature here? Resistivity depend on temperature and the nature of the conductor. What does nature here refers to? Any idea? The word nature here refers to the characteristic of the conductor, the length, the cross-sectional area. I mean, the factors affect the resistance in a way. That is meant by nature. I repeat, it is referred to the length and the cross-sectional area of the conductor. And this is the formula for resistivity. Okay, just now we write the combination of the formula relating all the 3 factors affect resistance in a wire. So when you arrange back and making the resistivity as the subject, so we have rho equal R A divide L. Okay, where rho itu is the resistivity, R is the resistance, A is the cross-sectional area of the wire, and L is the length. So how we get ohm meter? From this. Remember, the unit for resistance is in ohm. All right. Unit for area is meter squared, and the unit for length is meter. So when you simplify this, we can cancel off m down here, cancel off 1m up there. So the remaining unit is ohm meter. So again, what is resistivity? It is the conductor's ability to oppose the flow of electric current. How good the conductor oppose or prevent current to flow through them. Okay, so are you clear resistivity? What is the difference between resistivity and resistance? Can someone respond to that question? Apa beza resistivity dengan resistance? What is resistance? We learned earlier resistance. Resistance tells you the ratio, okay, the ratio of potential difference to the current flow. That is resistance, the ratio. Okay, resistivity means the conductor's ability to oppose the flow of electric current. So resistivity is bigger. Resistance, you can say resistance is the sub from resistivity. All right. So are you clear with the definition for resistivity? Student, are you following me? All right. You are doing good so far? Okay, thank you, Hui-san. Okay, so this is a few example of material together with their resistivity for each. We have 5 type of material there, 5 type of conductor: tungsten, constantan, copper, iron, and nichrome. Okay, and this is the resistivity for each given in ohm meter at temperature 20 degrees Celsius. So what can you say? Can you guess from this value? Can you say which material has a higher resistivity? Can you give me 2 material which have higher resistivity from this table? This table is provided in your module on page 30. Now, which one has higher resistivity, students? You can look from the value. They are all with the power of 10 negative 8. Okay, so which one has a higher resistivity? Is it tungsten, constantan, copper, iron, and nickel? Yeah, Qingxiang. So there are 2 of them has a higher resistivity, tungsten and nichrome. Okay, the first one is nichrome with 100, and then tungsten also considered as high if compared to another 3, which is very low. Okay, so you can say nichrome and tungsten are 2 types of wire which has high resistivity. So that's why they are always used as a heating element in an electrical appliances. Okay. Meanwhile, for iron, constantan, and copper, they are considered as a low resistivity wire, mean they have low resistance. Okay. Nichrome and tungsten has high resistance wire. So that's why constantan and copper, we always use it as an electrical wiring at home because of their low resistance. But if you look here, we have another wire which has low resistance. But why we are not prefer to use iron in electrical wiring? Can you think the reason? Why we do not use iron wire for electrical wiring even though it also has low resistance similar to constantan and copper wire? Kenapa tak guna wire besi, iron untuk pendawaian electrical wiring at home? Any idea? What is the disadvantages of using iron wire compared to constantan and copper in electrical wiring? Expensive. Hui Xiang say iron is expensive. Okay. Other than expensive, can you think another reason? Iron, constantan, and copper. Okay. They are, one of them is a pure metal. Another 2 is alloy, right? Iron is a pure metal which is rust easily. Besi dia sedang berkarat. Well, for constantan wire, they have better characteristic. They are not rusty, they are more stronger, they are durable and cheaper somehow. So that is the reason why we are not using iron as electrical wiring. The most reason is because it is rusty. Dia senang berkarat. Okay. Other than it is costly, agak mahal. Okay, so student, that is resistivity. Remember what is resistivity? conductor's ability to oppose current flows through them. Okay, so now let us go to our fifth learning standard. What is the applications of resistance in our daily life? Okay, so the first thing, let us take a look at the heating element. Okay, where can you see, where can you find a heating element in our electrical appliances? Can you give a few example of electrical appliances which use heating element? Okay, any example of electrical appliances use heating elements, students? Welcome, Sinsiang. Oven, yeah, very good. Okay, electrical oven. What else? What else? Electrical appliances using heating element. Rice cooker, yes or no? Electric kettle, electric iron. So that is a few example of electrical appliances use heating element. Hair dryer also have heating element inside. Okay, so what is the energy changes in a heating element, student? When you use heating element, so the energy changes is electrical energy change to heat energy. So you write this only enough. Electrical energy to heat energy. You write the first sentence only. Electrical energy change or convert to heat energy. Okay, then this is a few example of electrical appliances use heating element as I mentioned just now. Okay, the front word you don't have to write. Ini tak perlu tulis lah. Okay, you tuliskan saja. Iron, electric oven, electric kettle, and hair dryer, and many more, etc., etc. Okay. How about question C? Can you respond to question C? What is the characteristic of material so it is suitable to become a heating element? So what do you think the characteristic they must have in order to become a heating element? Anyone? Huisan, any idea? Yuqing, Jeb, Chen Yao, Jing Xiang, Ki Xian, Sun Xiang. We have Ong Zilin here, Ong Jin Pei, Jun Wei, and Wei Xiang. All right. Thank you very much for your commitment. Okay, so anyone, what is the characteristic of material that enable them to become a heating element? So you can say they must have high resistivity. Okay, means they must have high resistance. So when they have high resistance, they will produce large amount of heat. Okay, they will produce large amount of heat. Second, they must have high melting point so that they won't melt easily at high temperature. Any other characteristic you can think other than these two? High resistivity or high resistance and high melting point. Okay, anything else you can add, students? Small area, Qing Xiang, small area. Small area means small cross-sectional area. Yes, very good. Okay. And you can also say longer, longer. Okay. Another one you can say not corrosive. Okay, they should be not corrosive so they won't contaminate the water or the food. Okay, which you are heated using the heating element. They should be not corrosive. So they do not contaminate. Dia tidak mencemarkan makanan atau minuman yang you panaskan with the heating element. Okay. So this is on heating element. Okay, so now let us look more on heating element. This is on D, on nichrome. Okay, this is all the characteristic for one example of material which is normally used as heating element in most electrical appliances in the world, nichrome. Okay, nichrome is cheaper compared to tungsten. That's why we use nichrome a lot compared to tungsten. Okay, students. So it is an alloy with a high resistivity, about 100 times 10 negative 8 ohm meter at temperature 200 degrees Celsius. Okay, so you can highlight the point, high resistivity, you can highlight or underline. It has high melting point, 14,000 degrees Celsius. Very, very high melting point. Okay, and it causes no corrosive at high temperature. Plus, it experiences small expansion when heating. So, uh, the character, the structure does not changes much when you heat them. Okay, it only gives small expansion when exposed to heat, so it can use for longer time. These properties to make the heating element most efficient to be used as a heating element for electrical appliances. So are you done highlighting all these 4 points? High resistivity, high melting point, no corrosive, and small expansion. Okay. So we go to the next example, number 2, electrical wiring at home. So remember, for first heating element, we are using material with high resistance. So how about electrical wiring at home? What kind of material we normally use? I just mentioned it before. We are using copper. Okay, we are using copper. Why? Because it has low resistivity, mean low resistance. So this prevents the wire from heating up quickly when current flows through them. Can you imagine if we are assemble our electrical wiring at home using nichrome wire? What do you think will happen? All houses in Malaysia will be on fire then, because they generate a lot of heat when current flows through them. So that's why we are using low resistance wire in assemble the electrical wiring at home. Okay, so it doesn't generate heat too much when current flows through them. Okay, next student. This is another thing which is called fuse. Okay, an electrical component fuse. This is how a fuse look like. Okay, you can find them here. This is a 3-pin plug. So the fuse is there. This is the fuse. Okay, it is made from a very thin wire inside. Inside is called this. This is the cover. So where fuse can be found, student? Where can you find a fuse? Boleh jumpa di mana? Jangan kata boleh jumpa di kedai elektronik. Okay, in the diagram. Where can you find this fuse? Yes. Okay, di mana boleh jumpa? Okay, you can find them here in 2 places. The first one you can find on the main switchboard in our house. Semua rumah dia ada satu main switchboard. Normally kita tengok di mana? In your living room. Ada dekat ruang tamu you punya main switchboard. And then in a plug, okay? Phone charger, any kind of plug, they must assemble a fuse there, okay? For safety purposes. So what is the function of fuse, student? What is the function of fuse? Anyone? To break the circuit. Break the circuit when? When the fuse need to break the circuit, Wei Xiang? Bila dia kena putuskan, Lita? When there is an exceeded flow of current across the circuit. Bila ada arus yang terlalu besar, over. Okay. To control exceeded electric current flow, so to prevent the electrical appliances from any damage, and also to prevent fire. Kita tak mau alat kita ataupun rumah kita terbakar. Okay, so fuse, the function is to control exceeded electric current flows. Sampai sini pun sudah cukup. Okay, if they ask you for the function, to control exceeded electric current flows through appliances. Okay, what is the characteristic of material which is suitable to make a fuse, student? Okay, so this is a few characteristic. The first one, as you can see in the diagram, the wire used is very, very thin. Okay, very thin, but it has low resistivity. Okay, it is thin and at the same time it has low resistivity, mean low resistance, and has specific melting point that will melt when exceeded current flows through it. So this fuse is designed to melt easily when there is an exit current flows through it to prevent the electrical appliances from malfunction or burning. Okay, so ini fungsi dia to break the circuit or to control exceeded electric current flows through electrical appliances. Okay, are you done with this point, fuse? Can we move to page 14 now? Any questions so far? Okay, if you have anything to ask, don't feel hesitate, don't feel shy to type in the info messages. Jangan malu nak tanya. Or you can open your mic if they can function. Okay, students, so this is the table shows comparison between non-conductors and semiconductors. So what is non-conductor? Non-conductor is called as insulator. They cannot conduct electricity, mean they are insulator. Semiconductor, what is semiconductor? It is the material which can conduct electricity better than insulator, but not as good as a conductor. So it lies in between. Semiconductor, the conductivity is in between insulator and conductor. Conductor is better and insulator is poor than semiconductor. Okay, this is the resistivity. Non-conductor, it has the highest resistivity. Meanwhile, for semiconductor, again, the resistivity or the resistance is in between conductor and non-conductor. Example of non-conductor, plastic, wood, what else you can think? Rubber, paper, and etc. Okay. Meanwhile, for semiconductor, we have silicon and germanium. We will discuss this more on chapter 5 later on when we are dealing with electronics. Okay, students. So are you done with non-conductors and semiconductors? Okay. So in the second table, we have conductors and superconductors. Okay, conductors and superconductors. Okay, what is the difference between conductors and superconductors? Can I move to next slide, students? Okay. Okay, if you miss any point, don't worry. As I mentioned earlier, after we finish, I will share to you the full PDF copy, full answer for 3.2 resistance. So I think we can move to the next slide. Okay, this is the comparison between superconductors and conductors. Okay, what is conductor? A material that conducts electricity. Meanwhile, for superconductor, is the material conducts electricity without any resistance. Okay, conduct electricity at zero resistance, mean they are better than a conductor. And talk about the resistivity. For conductor, it has low resistivity, mean it has low resistance. Okay. Meanwhile, for superconductor, it has zero resistivity at critical temperature. Critical temperature also known as absolute zero. Do you remember absolute zero? We learned last year in chapter 4, gas law, absolute zero. It is 0 degree Kelvin or negative 273 degree Celsius. Okay, what happened at this temperature? A molecule is static. They are not moving at all. Okay, they don't have any pressure. They don't have any volume. Okay, so that is critical temperature, absolute zero. Okay, example of superconductor, students. Can you name a few? For conductors, we have iron, carbon, and any other metal. You can name them steel, aluminium, copper, zinc, and so on. Okay, for superconductor, okay, any idea? We have cesium. Okay, example, cesium at temperature 1.5 Kelvin or lower, and many more. Okay. Okay, so this is a few information on superconductor on page 14. So you complete the blank spaces with this answer. Okay, superconductor, what is superconductor? A material that has zero resistance. Okay, zero resistance, zero ohm resistance. Example, metal, ceramic, and inorganic material that can conduct electricity very efficient at specific temperature. When this material have no electrical energy loss, mean they can pass through 100% of the electricity through them. So no electrical energy lost in the form of heat because they don't have any resistance at all. Okay, either in the form of heat, sound, or others. Okay, and B, this is the graph shows superconductor. Okay, this is the resistivity. This is the temperature. This is the critical temperature. Okay, this is at normal condition where you can see when the temperature is lower, okay, you can see the resistance also lower. And when it reached the critical temperature, the resistance suddenly dropped to zero. Okay, as mentioned in point B. Okay, temperature decreases. When temperature decreases, you can see resistance also decreases until it achieves the critical temperature where suddenly the resistance drops to zero. So a material will become a superconductor at this temperature. And not every conductor can become superconductor. Only a few material able to do so. Okay, bukan semua conductor boleh jadi superconductor. Ada sebahagian saja yang boleh bertukar menjadi superconductor at this critical temperature. Okay, I hope you are clear with that. What is the difference between conductor and superconductor? Okay, student, just for your information, this one is off record, not in your module, sebagai tambahan saja. So we understand that all conductors material have resistance. Okay, even though very small, they must have some resistance in them. And this resistance will cause energy loss, okay, during the transmissions of electricity through the conductor. So in this year, a Dutch physicist named as Kamerlingh, or I'm sorry if I didn't pronounce it correctly, investigated the resistance of mercury. So he conducted a study on mercury, and what he discovered when mercury was cooled to a temperature of 4.1 K Kelvin. Can you tell me how many degrees Celsius is this? 4.1 K Kelvin equal to how many degrees Celsius? Do you know how to count? Resistance suddenly dropped to zero. So at this temperature, mercury has turned into superconductor. Okay, can you convert 4.1 K Kelvin into degrees Celsius? How to convert? Macam mana nak kira? Okay, you learn before in form 4. Critical temperature 0 Kelvin. Ini bukan okay, ini 0 Kelvin equal to negative 273 degree Celsius. Okay, so which mean 4.15 Kelvin, so equal to negative 273 plus 4.15 degree Celsius. Okay, can you count berapa? Negative 273 plus 4.15 degree Celsius. Berapa? Cuba tolak. So you'll get the answer in degree Celsius. Okay. Okay, next students. Okay, so this is the graph show from his study where this is the resistance of mercury and this is the temperature in Kelvin. You can see that as when the temperature drop, the resistance also drop. When the temperature suddenly dropped to 4.15 Kelvin, now the resistance in the mercury becomes zero. Okay, so at that time, mercury from conductor has turned to become superconductor. Okay, okay, next. Okay, this is how superconductor looks like. Okay, and when you place a superconductor in a magnetic field, what happened to the superconductor? You can see that they will produce an effect which is called a levitation effect. You can see that the superconductor is floating on top of the magnetic field. Okay, this one we say when a superconductor is placed on the magnetic field, superconductivity effect occur. So it will produce induced current that flow continuously around the superconductor, and force will be produced, so it will causes the superconductor to float or to levitate above the magnet. Okay, you pernah dengar tak maglev train, magnetic levitation train? The train is not in contact with the track, as if the train is floating, floating on top of the track. Kereta api tu dia macam terapung, so it doesn't touch the track at all. So they design maglev train in order to reduce resistance between the train and the track. Okay, so the train won't be burned when they travel in a longer distance. Itu tujuan dia, supaya kereta api tak mudah terbakar bila dia in touch with the track, because both are metal, so very high resistant, very much heat will be generated. So in order to prevent disaster, so they use this effect, levitation effect. So that's why we have maglev train, magnetic levitation train. Dalam kat Jepun ada banyak lah. This is example of maglev train. Very fast, and then it doesn't come into contact with the track at all. So as if the train is floating above the train due to the levitation effect, the superconductivity effect. Okay, students. Later, I show you one example of video in your Telegram group because here, when I play, the sound does not come up. So later you can see what is maglev effect. Okay. So these are a few advantages of superconductor in our daily life. First, it can maintain high current. Okay. And loss of power will be too small. It prevent or reduce power loss during transmission of electricity throughout a very long transmission cable. Okay, and number 3, no energy loss. And number 4, small motor and generator can be used. Okay, so we don't have to need a very bulky motor and generator to generate current. Small motor and generator is enough, okay, to generate high current when we are using this superconductor. Okay, so that is to do with superconductor. This is the video I mentioned to you just now, but I believe when I play, the sound does not come out. Can you hear the sound? Tak dengar kan? Okay, never mind. Later you can watch this video when I show them when I share them in your Telegram group. Okay, that's all to do with 3.2.5. Okay, so now we come to the final learning standard for resistance is to solve problem involving the formula of wire resistance. Okay, just now you write the formula relating resistance, resistivity, length, and cross-sectional area of wire. Okay, now how to apply this equation? Okay, let us try to do this question together. In activity 2, we have 4 questions altogether. Student, okay, first question. Find the total resistance for a roll of copper wire with this length 10 meter. It has a cross-sectional area of 2 mm squared. Given the resistivity of the copper at temperature 20 degree is 1.72 times 10 negative 8 ohm meter. So what are we looking for here? We are looking for resistance, R. Okay, the resistance of the copper wire. So the first thing you must do when try to deal with calculation, as I always advise, you can extract all the given information, list out, or highlight, underline all the given information. So you are given with L, and you must familiar yourself with all these symbols, so you can work well with the formula later on. Length 10 meter. Okay, this is the area given. Area given is in millimeter squared. So you have convert them into meter squared. Okay, I give you last time the conversion for meter to millimeter squared, and then from meter into millimeter cube for volume. Okay, so for area, millimeter squared, convert to meter squared, multiply 10 negative 6. Okay, and this is the resistivity, rho given 1.72 times 10 negative 8. So we are looking for R. How to find R when you are given all these three? So what is the formula we apply here? So you can check back the formula you write just now on page 13. Okay, on page 13, the formula is there in the box at the top left corner. So this is the formula for resistance. Resistance is equal to resistivity multiply length divide by cross-sectional area of wire. Okay, can we count together? What is the value for resistance here, students? So you can do your substitution. Okay, this is the value for the resistivity, this is the value for the length, and this is the value for the area. Okay, count together. Please work out with this question and see you can get similar answer to me or no. If you are done, you can share your answer in the in-call messages. Okay. Okay, Junwei get 0.086. How about the rest? Do you agree with Junwei, students, or you have different answer? Okay, I hope everybody is doing this. Yes, very good, Junwei. Okay, so you just do the substitution. Okay, for resistivity, and this is for length, and this is for, just work carefully with your calculator. So the value is 0.086. And don't forget the unit. It is ohm, since we are looking for resistance. Okay, so easy, right? So you determine, you extract all the information and then determine the formula and substitution, final answer with correct unit. Simple. Okay. Okay, now second question. Question number 2. Okay, now we have Ahmad. He bought a roll of aluminium wire with the radius. Okay, this is the radius, 0.5 mm. It has the length of 500 meter. Okay, and given the value of resistivity as stated, 2.8 times 10 negative 8 ohm meter. So again, find the resistance of the aluminium wire, students. So we apply the same solution as in number 1. So, but here you have to be careful. They give you the radius. They don't give you the area. So how we determine the area for the wire, student? How to determine cross-sectional area of a wire? How to find cross-sectional area of wire? Anyone? Area. Area is given by, the area of our wire is a circle, right? So how to find area for circle? It is pi r squared. Okay, pi r squared. So from the radius, you can find the area. So this is the length, 500 meter. The resistivity is given. The radius is given 0.5 mm. So you convert first into meter. Okay, so 0.5 mm is equal to 0.0005 meter. Divide by 1000. Okay, so we'll give you 0.0005 meter. And then only we find the area, pi r squared. Okay, the cross-sectional area of the wire. So then again, the formula. Okay, resistance. So you just do the substitution. Okay, what is the value you get here? Can you determine? Did you get 17.823 as shown here? So this is the resistivity as given, the length of the wire 500 meter, and this is the area. Okay, pi multiply with the radius squared. Did you get 17.823, Qing Xiang? Zilin, did you get 17.823, Jinpei? Yes, okay, very good. How about you, Junwei? Dapat tak? Chun Yao, Kerwin, welcome. Okay, we are now discussing page 13. Page 14 in your module. Muka surat 14, activity 2, question number 2. Okay. So don't worry if you miss the first part. Okay, you can watch back the recorded video for this session. No problem at all. Okay. Did you get, student, everyone? Did you get 17.823? And don't forget the unit as well. It is in ohm. Okay, very good. Okay, now let us move to our third question, students. We have a coil, okay? Coil of pure copper wire with a length of 500 meter. Again, they give you the radius 0.5 mm. It has resistance. Now the resistance is given 10.8 ohm. So you have to find the resistivity. Okay, so you can find the resistivity. So here we apply the same formula, only now we are looking for rho, resistivity. So again, the information, very important. You have to extract out length 500 meter, radius given 0.5 mm. So in meter, it is 0.0005 meter. Okay, and this is the resistance given 10.8. So from the radius, we can determine the cross-sectional area of circle pi r squared. Okay, so by this, how to find resistivity? So you have to rearrange back the formula. The formula is like this, right? R equal rho L divide A. So now we are looking for this. So means A we have to bring to this side. So it become AR, ORA, and L we bring to the other side, it will lies down. Okay, it will go here. So this formula will become rho equal RA divide L. Okay, so this is how we change the formula from one and another. As shown here, resistivity equal to resistance multiply area divide its length. So you just fill up with you substitute with the value. This is the resistance, this is the area, pi r squared, and this is the length of wire. Did you get 1.697 times 10 negative 6 ohm meter? Same answer with me or different? Okay, try to come out with this value. Okay, get it or not? 1.697 times 10 negative 6 ohm meter. Remember, when you are doing your calculation, you must leave the final answer at least 2 decimal places. At least 2 decimal places. Get it, Kawin? Try to calculate the resistivity. Is it 1.697 times 10 negative 6? Can. Okay, very good. So I hope the rest also can find this value. It's a very simple mathematics all to do with the substitution. Okay, student. Last question for activity 2. Number 4. Now they give you the current. Okay, the current flow through a zinc wire of length 1 mm is 1 ampere. So this is the length, 1 mm, and this is the current, 1 ampere, I. Current is I. Find resistance of wire. So what is the resistance? We are looking for resistance in A. Second, what is the value of potential difference between two ends? So potential difference is voltage, V. So how to find R, how to find V. Okay, this is the information you are given. First is the resistivity. So this is rho resistivity. And can you please add another information, another missing information there is the radius. Okay, radius of the zinc wire, 0.5 mm. Okay. Radius is missing, so you please add this information. The radius of zinc wire given 0.5 mm. So you just follow solution number 2 and solution number 3 to find the area when the radius is given. Okay, so I give you 30 seconds to find the resistance. Can whoever done, you can share your answer in the in-call messages. Okay, take your time and try to find what is the resistance of the zinc wire we are looking for here. If you're done, just type your answer in the in call messages. Okay, I hope everyone is doing well there. Kisian, we have Kevin, Chun Yao, Xing Xiang, Sun Xiang, Zerlin, Jin Pei, Jun Wei, Wei Xiang, and Hong Zhe. Okay. So have you find the resistance of the wire? Find resistance as you find in question 2 and in question 1. Okay, in question 3, we are looking for resistivity, right? So find resistance as you find in number 1 and in number 2. Apply the same formula. So we are given with L, we are given with rho resistivity, and you are given with the radius, so you can find area first. Then from there, you can solve for R, the resistance. Yeah, what is it, student, the value? Okay. So I show you the answer. Later you can compare, or you need more time to find them. Resistance. Okay. Xing Xiang. Macam mana dapat 1.75 times 10 negative 5? Okay. Okay, this is the resistance. Okay. So we are looking for R. So the formula, make sure you write the correct formula. The formula for resistance is rho L divide A. Okay, rho L divide A. Rho is the resistivity, L is the length, and A is the area. This is L, length. Okay, so this is the resistivity, 5.5 times 10 negative 7. Okay, the length here, you have to be careful. The length here is given is in mm. So you have to convert into meter. 1 mm, how many meter? 0.0001 meter. Or 1 times 10 negative 3 meter. Okay, and this is the radius. Okay, so you convert into meter also. So it will be 0.0005. Then only you can find this resistance. 7.002 times 10 negative 4 ohm. Okay, this is the information given for this question. Length, okay, see, this is the trick. The trick is here. You can be trapped. The length, millimeter, convert into meter first. And then the radius as well in millimeter, convert first into meter. And find the area by area of circle, pi r squared. Okay, so then only you. Can you press this? Did you get 7.002 times 10 negative 4? When you solve this, dapat tak jawapan ini? 5.5 times 10 negative 7 multiply with 1 times 10 negative 3. Yes, very good, Wei Xiang. Okay, divide with this area. Okay, and second question, you can apply Ohm's law. Okay, apply Ohm's law to find potential difference V. Okay, since we know I is given 1 ampere and R we have calculated in the first part A. So we can find voltage current multiply resistance. So the current is 1 ampere given in the question. R has been determined from A. So it is 7.002 times 10 negative 4. The answer is different, only different. The answer is the same, only different in units. Okay, this is the unit for voltage or potential difference, and ohm is the unit for resistance. So are you clear with question 4? Question 4 is quite tricky, so please don't get trapped. Okay. So student, I guess that's all with the discussion for 3.1 until 3.6, 3.2.1 until 3.2.6 resistance. It's quite long, but I guess nothing very much difficult. Okay, how do you think resistance? Can you deal with resistance? Boleh tak? Okay, so let us check your understanding by doing a few example of question in the objective part. Okay, malam ni kita cuba buat objektif saja. Overall has 14 question. Then for the structure and essay, I hope you can spend time to do them and I will share to you the full answer so later you can check back. Okay, you try to do first and then if you find any difficulties, then only you refer to the answer. Okay. Okay, try this one. Number one, student. Which graph show relationship between potential difference and current for ohmic conductor? Ohmic conductor is a conductor which obeys Ohm's law. So Ohm's law say what? Potential difference is directly or inversely to current. Ohm's law. It say what? V inversely proportional or directly proportional to current? Yes, directly proportional. So which graph show V directly proportional to I? A, B, C, or D? Yes, very good. Answer is B. Okay, then second question. Which circuit can be used to determine resistance of a bulb? So if you look at this four circuit, all has voltmeter and ammeter. Remember how ammeter and voltmeter should be connected to a resistor. Voltmeter, which one should be connected in parallel? Which one should be connected in series to the circuit, student? So which circuit is correct? A, B, C, or D? When you answer, can you type together the number of questions so I will understand which question you refer to? Okay, for number 2, 2A, 2B, 2C, or 2D? Remember, ammeter must be connected in series. Okay. Meanwhile, voltmeter must be connected in parallel with our load. So we have bulb here, which means ammeter must be connected in series with the bulb, while for the voltmeter must be connected in parallel with the bulb. So which one is correct? Is it? Yes. So you can see very obvious. The answer is D. Okay, D, you see. Ammeter connected in series with the bulb. Okay, ammeter in series with the bulb. And then voltmeter is in parallel with the bulb. Here, what's wrong? Voltmeter, correct, connected parallel with the bulb. But ammeter also connected in parallel. Salah lah, ammeter tak boleh letak sini. It must be placed somewhere here or here. Okay, B, what's wrong with the diagram? Sama juga. Ini sama ke? A and B is the same. Okay, so this one also wrong. Okay, how about C? What's wrong with C? The voltmeter and ammeter position is opposite. Terbalik. Supposed to be here is ammeter, voltmeter supposed to be here. Okay, remember ammeter connected in series, voltmeter connected in parallel with our conductor or any electrical devices. Okay, number 3, student. Question 3. Okay, you are given a graph of V against I, potential difference against current. Which conductor has the highest resistance? How to find resistance from potential difference against current? It is determined from the gradient. Yes, very good. From the gradient. So which one shows highest gradient? P, Q, R, or S? Definitely P. Okay. The graph is the steepest, mean highest gradient. Okay, how about number 4? Which factor does not influence resistance of a wire? Remember, we have 4 factors affect resistance. Length, temperature, cross-sectional area, and resistivity. So hardness is nothing to do with resistance. Yes. Number 5. Which of the following is an ohmic conductor? Ohmic conductor means a conductor which obeys Ohm's law. Mean V directly proportional to I. Yes, constantan wire. Very good. Another 3 is non-ohmic conductor, which means V is not directly proportional to I. Yeah. Number 6. Okay. This is the control knob of a speed regulator of a fan. Tengok kamu punya kipas di kelas ada speed regulator. So which physical varies when the knob is turned? When you turn to number 1, number 2, number 3, number 4, which physical quantity varies when the knob is turned? Okay, so it must be related to this topic somehow. So the answer is yes, resistance. Very good. Okay, number 7. Electrical circuit is given in diagram 10. Which changes to the wire will produce greatest reading in emitter? Student, greatest reading in emitter. Greatest reading in emitter mean the current is high. Emitter read current. So to find high I, it means resistance must be low or high. To produce high current, high emitter reading mean the resistance, yes, the resistance must be low. So which changes will produce low resistance in the circuit? Length of wire, diameter of wire. Longer wire or shorter wire give you low resistance? Diameter, bigger diameter or smaller diameter give you lower resistance? Yes, it must be short. Remember, shorter wire, lower resistance. Okay, how about the diameter? Which diameter? Yeah, so bigger diameter. Remember, bigger diameter give you lower resistance. So which one is the answer? So obviously, it is C. Remember, length directly proportional to resistance. Diameter inversely proportional. Yes, so the answer is C. Shorter wire, bigger diameter give you lower resistance. So high current flow through the emitter, mean higher reading. Okay, very good. So number 8, student. Number 8. Voltage current graph. We have VI graph. VI graph, it shows a straight line from the origin. Which circuit is used to obtain this graph? So which circuit show ohmic circuit, which obeys Ohm's law as shown in this graph? Okay, which one? So ohmic circuit must have what? Must have emitter connected in series and must have voltmeter connected in parallel with our resistor or with our electrical devices. So which one? So now you can see clearly. A cannot because there is no resistor there. So we cannot see what is the relationship between A and B. C, what is wrong with C? What is wrong with C, student? A, nothing wrong, but V is wrong. V is supposed to be connected in parallel with the resistor or with any electrical devices here. What is wrong with D? What is wrong with D? Ada masalah tak D ni? Apa yang silap? What is wrong with D? The voltmeter. Voltmeter should be placed here, okay, parallel to our load. Emitter, no problem. So the answer is B. Emitter in series, voltmeter in parallel. Okay, number 9, student. Okay, this one you have to calculate. This is the electrical circuit. Voltage is 12. We have one resistor here with 4 ohm and another resistor here with unknown resistance, which is R. They only stated R. The voltmeter reading here show 8 volts. So here show 8 volt. Can you find the current flow through resistor R? So what is the current flow through resistor R? How to find? Okay, how to find? It looks like difficult, but actually very easy. Okay, so if you understand, this is a series of parallel circuit. We have 2 resistors there. Are they connected in series or in parallel? They are in series. Okay, they are in series. So for series, what is the total voltage for series connection, student? For series connection, this one 8 volt. This one mean 4 volt. 4 volt in resistor R. How about the current flow in both resistance? Are they different or the same, student? For series circuit, the current flow through these 2 resistors are the same, which means if you can find the current flow here, the value will be equal to the current flow through resistor R. So how to find the current flow towards the 4 ohm resistor? Answer is A. So this is how to find the current flow in the 4 ohm resistor. I equal to V divide R. The voltage is 8 here. The voltage given 8. 4 ohm is the resistor. So current flow here is 2 ampere. So as I mentioned, they are series. So the current flow through 4 ohm equal to the current flow at the R resistor. So the answer is 2A. Very simple. Okay. Okay, number 10. Number 10, quickly. Okay, this one. Just choose. Which graph show correct relationship between resistance and length? Okay, what is the relationship between resistance and length? Again, directly or inversely proportional? Direct or inverse? Resistance and length of conductor. It is directly, yes, very good. So which one show directly proportional? Mestilah B, resistance directly proportional to length. Okay, number 11. Okay, we have 3 bulb here. This is the symbol for bulb. Bulb 1, bulb 2, bulb T. They are all identical. Identical mean they have the same resistance. Okay, same amount of resistance. We place 3 emitter there. A1, A2, A3. Okay, which statement is correct on the reading of A1, A2, and A3? Which emitter shows greatest current, student? Current flow greatest at the main circuit. This is the main circuit. So the current here is the greatest, number 1. Second, so what happened to the current flow here? So we have 2 junction, right? We have 2 branches. So the current will be divided into the first branch and then to the second branch. Okay, here we have 2 bulb. Here we have 1 bulb, which means the resistance at this junction is higher because we have 2 bulb. Okay, here the resistance is lower because we use 1 bulb only. Okay, so the current flows more to the less resistance and it will flow less to the higher resistance, which means A1 greater than A3 and then greater than A2. Okay, so can you see? Answer is B. Yes, very good. Answer is B. It's young. A greater than A3 greater than A2. Can you see this, everyone? Okay, let's say the current here, let's say we have 3. Okay, 3 ampere. Okay, 3 ampere. So this 3 ampere will be divided. Okay, which means, just for an example, so 2 ampere will flow to the lower branch. 1 ampere will enter the top branch. So when they meet back at the end of these branches, so they will combine back, become 3 ampere. Okay. Since here the resistance is higher, so lower current will enter this branch. Here resistance is lower, so higher current will enter this branch. Okay, so I hope you are clear with that. Okay, last 2 questions, last 4 questions. Number 12. Again, we have identical resistor. Now we have 5. Resistor 1, resistor 2, resistor 3, resistor 4, resistor 5. Okay, emitter A1 reads 1.2 ampere. Okay. What is the reading of emitter A2, student? Ini perlu kira tak? Sebenarnya you tengok saja, tak perlu kira. Okay, very simple calculation only. Tak perlu guna calculator pun. Okay, how to see this circuit? So to find the emitter reading in A2, you must first know what is the main current flow in this circuit. So what is the main current flow? Can you tell me what is the main current flow? Here is 1.2 ampere. So what is the main current flow? If I place emitter here, it will read how many ampere? Dia baca berapa ampere di sini. Actually from this you can get the clue. Okay, so the main current here will be divided equally into these 2 branches. Why equally? Because they have same resistance. It means when this is 1.2 ampere, down here also 1.2 ampere. So this will tell you the total amount of current flow in this circuit is 2.4 ampere. Okay, 2.4 ampere. So after they meet at this end of these branches, so they will combine back, become 2.4. And now this 2.4 will be divided into 1, 2, 3 branches. And again, divided equally since all are identical, which means 2.4 divided by 3, how many you get? Which means 0.8 will flow to the top branch, 0.8 will flow to the middle branch, and 0.8 ampere will flow to the lower branch. So when they meet back at the end of the branches, they will become 2.8, 2.4 ampere again. and the cycle continues. So yes, the answer is 0.4 ampere. So I hope you can see the idea how to find the reading of ammeter wherever they place it at. So you have to understand the series and parallel circuit. Okay, number 13, student. We have 4 bulb, bulb A, bulb B, bulb C, and bulb D. Which bulb, when faulty mean not function, when they suddenly blow. So causes all other bulb to not light up. Which one, student? Mana yang kalau dia rosak, semua pun tak boleh menyala. Is it A, is it B, is it C, or is it D? So you have to check one by one. Okay, let's say A is faulty. Kalau A rosak, can the current flow in the circuit? It can flow through B. Okay, it can flow through B and flow through D, which means B and D still can light up. Okay, if A is faulty. Okay, then we try. Then, how if C is faulty? Kalau C rosak, apa jadi? So the current cannot flow through here. Okay, so A cannot light up. Okay, but B and D still can light up because this is the path that can take. Okay, so done. So A is not the answer, B also not the answer. Okay, how if C is faulty? Kalau B yang rosak pula, macam mana? If B is faulty, so the current will flow through these branches, flow through A, flow through C, flow through D. All three will be light up. Okay, so no problem. How about D? If D is faulty, kalau yang rosak itu D, okay, sini rosak. So the current cannot flow here. The current is not completed, cannot flow. So the current flow here also not completed. Okay, it doesn't reach the negative terminal. So when D broken, all cannot light up. So which one is the answer? Yes, the answer is D. Okay, the answer is D. If D broken, all another three cannot light up. Okay. Okay, last two questions. Sorry, we have excessive 10 minutes already, 9:40. Okay, last two. Okay, students, for tonight. Okay, we have electric circuit. 2 ohm resistor, 4 ohm resistor, 4 ohm resistor connected in parallel. Okay, the reading of ammeter. Find the reading of ammeter. What is the current flow in this ammeter? Okay, how to find? So first you have to solve this. What is the effective resistance here, student? 4 arranged in parallel. This will give you 2 ampere. Okay, kalau dia sama senang nak kira. Divide 2 only. 4, so become 2. So 2 plus 2, the effective resistance in this circuit is 4 ohm. Okay, so we have V, 3. So we can find I, where I is V over R, which means 3 divide 4. So what is the answer for number 14? It should be boy at 0.75 ampere. So the idea is to find the effective resistance first. You solve the parallel connection first. 2A, this is 2 ohm. Okay, 2 ohm. And then add with the series, 2 plus 2 give you 4 ohm, the effective resistance, total resistance in the combination circuit. Then from the formula, we can find current is 0.75 ampere. Okay, last question. 24, diagram show resistor P, resistor Q, and resistor R connected in series. So how P and Q are connected? This is very simple. How Q and R are connected? Which one connected in series? Which one connected in parallel? Ulang sekali yang mana, Wei Xiang? Number 14. Okay, we finish number 15 first. Then only I repeat number 14. Okay, we finish 15 first. Okay. How does P and Q connected, student? P and Q, how does they connected? Series or parallel? Series or parallel, this one parallel. Okay, you can see a junction there, so it is parallel. How about Q and R? Q and R, they are in series. So the answer for number 15 is C. Yes, very good. P and Q are parallel, Q and R are series. Okay, number 14. You want me to repeat number 14? Okay. Which one is the difficulty? Apa yang you tak faham di sini? To find. Okay, so if I ask you what kind of circuit, okay, semua tak faham, no problem. Okay, so what kind of circuit we have here? This is what we call as a combination circuit, right? Combination. Combination of these two are connected in parallel. Okay, and then they are in series with this 2 ohm resistor. So if you simplify this circuit, you boleh lukis semula circuit ini. You can simplify. This is the 2 ohm resistor. So this one, if you simplify, so now it become 2 ohm. Okay, so this is our battery, 3 volt. Okay. So this is after I simplify this circuit. Mean I settle this one first, the parallel junction. The total resistance. How to find 1 over R? Remember the formula 1 over R equal 1 over 4 plus 1 over 4. So here 1 over R is 2 over 4, which means R is 2 ohm. So R here in this junction is 2 ohm. Are you clear with this? That's why here we have 2 ohm. Okay, and then this 2 ohm is in series with the first 2 ohm resistor. So now the total effective resistance for series is 2 plus 2. Okay, 2 plus 2, so 4 ohm. We find 4 ohm. Okay, 4 ohm. So now we can find current, where R is 4, V is 3, by using the Ohm's law equation, where I equal V divide R. So V is 3, effective resistance for this circuit is 4, so give you 0.75 ampere. Okay, did you see it now? Sekarang boleh faham tak? So if you are given a combination circuit, the clue is, the tips is, you solve for the parallel junction first. You kena selesaikan ini dulu. Find the resistance for the parallel junction first. Then by this formula, ini formula to find resistance for junction. Ini 1 over R equal to 1 over R1 plus 1 over R2. Kalau you ada 3, plus lah. And then jangan lupa invert. Don't forget to invert to find R. And then you add with the resistance for series. So this is the effective resistance in the circuit, 4 ohm. Then only we can find current flow through the circuit. Okay. So I hope you're clear now with the solution. If you have any difficulties to understand any point, you can always refer back to the recorded video. Okay, so before we end our session, again, for those who enter late, our physics extra classes will be held from 11 to 28 October for every Tuesday and Friday, 8:30 to 9:45 p.m. Okay, means started from tomorrow. Okay, tomorrow I won't be in school because I have to attend a seminar. So monitor Jeb and monitor for 5 Paiduri, please go and get the new module in my place in Bilik Data. 3.4 and 3.3 and 3.4. I staple them together. Cikgu sudah staple siap-siap 3.3 and 3.4. But the room is now is a restricted zone for student. Bilik itu sekarang menjadi zone larangan murid. So kamu kena minta permission dulu sebelum masuk. Don't just simply enter. Kalau ada cikgu di sana, kata saya nak ambil modul from Cikgu Hasnita. Okay, boleh ya? Okay, so I guess that's all for tonight, students. Thank you very much for your cooperation. Before that, any last question before we end our session this evening? So I hope you are clear with this lesson. Kalau ada apa soalan, tolong jangan malu dan segan untuk tanya. Okay, tanya di kelas ke, tanya dekat Telegram group personally, or you can ask another friend who you can lies on. Okay, so again, thank you very much. So I see you again tomorrow, I guess, with 3.3 effective EFF, what is the cikgu sudah lupa dah topik dia, EMF, electromotive force and internal resistance, sorry. Okay, so again, thank you very much for your time. Teacher really appreciate your effort and commitment. So bye-bye everyone and see you again tomorrow. Okay, thank you.